Algebra 2 Cram, New York State Algebra 2 Regents, Common Core, Basic Graphs of Trigonometric Functions, Domain of the Cosine of X. Number 3. All right, so to order this complete Cram session, inbox me at memedicine@gmail.com. And if this is not the subject you're looking for, still inbox me at memedicine@gmail.com to inquire about pricing and ordering instructions for other personalized packages. Okay, be sure to spread the word to your friends and classmates who also need to cram. All right, so hold your horses, hold on to your seats. Let's explore or cram through the domain of cosine x. All right, the domain of cosine x. And before we actually get into this, I just need to orient you really quickly. So here we have a Cartesian coordinate xy plane, our origin, and we have an angle rather, coming out of the origin with the initial side being on the positive x-axis and the terminal side ray being within quadrant 1. Hence, it's an acute angle. Acute angles fall between 0 degrees here and the quadrantal angle 90 degrees, which we're so familiar with. It's so infamous. Here goes the formation. When you draw out the path of the x-coordinate and the y-coordinate for this ray, here goes a formation of a right triangle, okay? So the cosine x is going to be the x-coordinate, not the measure of this x, right? Divided by the magnitude of the ray, which is also the hypotenuse, or the longest side of the triangle. So this is a magnitude measure, meaning it's always going to be positive, whereas this isn't. It's just identification of the coordinates. So the x value can be negative or positive, okay? That's a quick cram review. That's just something I want you to recall. All right, so for the actual question, what is the domain of the function? Y is equivalent to the cosine x. Here we have cosine theta because we don't want to double up on the x variable since we're using x as our x coordinate, okay? So yeah, variables, remember, are arbitrary depending on what your situation is. Definitely press pause if you need to. Draw out your graph and I'll give you a moment to think. All right, so hopefully by now you were able to come up with an answer, and if not, that's completely fine. Let's cram through this together, okay? So here we have the graph of y is equivalent to the cosine of x. Isn't it beautiful? Well, not in my mind at least, it's monstrous. But for some of you, this is actually gorgeous. It's like, I don't know, mathematical heaven. I have no idea what you think about this. All right, so what I want you to recall is that the domain of a function is the set of all possible values of the independent variable, okay? Those are the values that occur on the x-axis, and they're usually called x or input variables for those of you who are more scientific and you prefer scientific jargon. Okay, so the answer is that the domain of the cosine of x is all real numbers. But, you know, just memorizing this is not enough. So we're going to cram again through a really monstrous number journey. I am not writing all this out. You need to just listen very intently and carefully. And if I'm talking too fast for you, you need to play this on 0.75 or half speed in your settings menu on the, I think it's the lower right hand corner of this by right clicking. Anyway, so all real numbers. A real number is a value that represents a quantity along the number line, or for those of you who are more comfortable thinking of it in this way, the x-axis, okay, since here we have trigonometric values. Well, we're in like radians for this independent variable axis. Okay, so real numbers include all rational numbers. Rational numbers can be written as a over b. This I actually might have to write. So a divided by b, where b is not equal to 0, but can be 1. So essentially, any number can be written as a over b, okay? And when written as a decimal, rational numbers terminate or they repeat. So examples of rational numbers are like -5, which would occur somewhere over here, or 4/3. It's a little bit more than 1. It would occur somewhere over here. Okay. And -5 is an integer. Integers are just counting numbers that you find on the number line, such as 0, -2, or +1. So the -5 example that I gave you as a rational number is, in fact, an integer, okay? All right. Real numbers also include, here we go, irrational numbers. Irrational numbers cannot simply be written as a over b, where b is not 0. And when written as a decimal, irrational numbers, they don't terminate or repeat. So a quick example is the square root of 2. All right, if you write this as any number, the implied value of b is always going to be 1. This is not rational because the actual value when you take the square root of 2 is going to be 1.1421356 ... I don't know the rest of the values that come after that. So again, I want to emphasize that real numbers include basically rational and irrational numbers, okay? So sorry for that long aside, but I hope you enjoy this cram. To order the complete session, again, inbox me at memedicine@gmail.com. And the odds of you doing exactly what I tell you to do is pretty slim to none, but I guarantee that if you cram with me, you'll become an Algebra 2 master, as well as other areas. So yeah, definitely inquire about other topics and subject areas as well. Okay? All right, I hope to hear from you soon. You better order.